It is my pleasure now to next bring to the stage Steve Sutherland, the founder and CEO of CrossWing Robotics. I mentioned it in his bio in the beginning, but Steve is leading a new project called Trellis, which is a micro rail direct autonomous transit system that he will be discussing. CrossWing, also similar to Vivek and CyberWorks Robotics, uses QA consultants and their xCOG testing solution. I will turn this over to you, Steve. We welcome you to our virtual stage today.
Great, thanks, Jennifer. Hey, it's fun to be with you today. I know there's probably a lot of people, on the video call who have got different robotics projects and AI projects on the go. And one of the things I'm going to show you very quickly today is some of the projects we have and some of the fun challenges that we have in the future. So if you can just go to the next slide. Here's an example of CleanBot Air. So this model tracks people as they're in groups and then moves itself in close and tries to recirculate the air in very high volume, 500 CFM per unit next to them. Of course, this could be used in a retirement home. In here, we show it in a classroom while kids have their masks off while they're having lunch. But if you think about the challenges from a software perspective, this is attempting to learn from the environment. What is a dynamic obstacle? Now, we all know we can recognize faces. That's pretty common. But what happens when a robot's trying to determine, hey, where should it go? If there's 2 or 3 different crowds, how should it prioritize? How can it communicate? And of course, how can you test that? Sorry, next slide. So we have a couple of other robots here that are part of the CleanBot line. That green one in the foreground on the left there, you'll see some little holes depending on the resolution of your screen. It's great fun. That robot can spray a liquid disinfectant at different obstacles that it comes across, different things that it thinks people would have touched. And these aren't always static. So in the picture above, you see there's a fire alarm button. That's not normally touched. It should go around that, but the door handle. And what about that cabinet behind it? You can see a fire hose. And these are things that in the ideal world, and we think this is coming quickly, people will be able to tell the robot, hey, when you're going through this room, make sure you do the elevator button, or make sure that you do the frame of the door, because people hold on to that for stability. So we're very excited by where we think robotics are going in terms of the communications with humans in their proximity. We were founded in 2006, and we build robots for OEMs and of course for our own offerings. But through that time, we think the biggest change is going to be when people are really communicating. We show in the top right-hand corner a smaller one of our robots, Virtual Me, and that's a gentleman who's telling the robot, hey, I'm not feeling the greatest. And I've got to walk down the corridor. And if they just had a knee done, an athlete with a knee, they might want to know that the robot's there with them. So robots that follow people. Now, the challenge is how do you test all these different scenarios? Because if we just test within our own environment, do we really learn what the AI is going to do in new situations? So the challenge, of course, is how do we simulate all these challenges that are really too costly in a physical lab? And how can we implement a solution where we can evaluate our code against others' code, so other people's code? What is the standard for this? What is the standard for the ability of robots to meet a threshold before they're let loose? So let's jump to the next slide just briefly. Here you see the classic test scenario. We have these test harnesses, because if you take our Bishop platform, which is up to 6 kilowatt hours of energy, and you crash it into the wall, it's really designed, it can do heavy duty security. It's really designed for protecting itself. And if it were to hit a wall, it's going to do some damage. So we have lighter test units. And then, of course, you have the tester who's trying to video maybe what the unit did at certain times. And this is, of course, always the same location. It's very time consuming. It's very costly. So jumping to the next slide, let's talk a little bit more about where we see AI systems going in the future. So Trellis Transit is a completely autonomous micro-rail-based system, which is just above the traffic. And it's not just for delivering people, it's goods, services, and people, waste pickup. And so the cities don't necessarily start looking quite the way we envision them down the road. This is an example of a city where you have a classic LRT and Trellis, but you don't get a lot of benefits. But you'll see in a moment there's some huge benefits going forward. Sorry, next slide. Just very briefly here, Trellis is about 2.5 meters wide. Two people can sit facing each other, or you can have a wheelchair go in, or as I mentioned, other robots carrying goods and services. And bicycles can be hung on, et cetera, et cetera. In fact, there's a version that will reach down and pick up bikes to redistribute bikes in the city. Next slide. So the question really is, how can Trellis ultimately be used? If you had a dedicated grid, microrail grid, and these are all level crossings, by the way. So when Trellis turns, it's much like how a car turns. It has to know that there's a right of way. Now, it doesn't stop. The goal is that no Trellis pod will ever stop. They'll always be synchronized. It's as if you approached an intersection with a car, and as you were going through that intersection, you knew that the car that was coming the opposite direction would miss you by a few feet. So this is some pretty hectic testing in order to ensure that we can pack as many people on the grid. But at that point, you now have an ability to move the goods and services and people all above the congestion with limited, very, very low energy footprint. The rails are composites and the pods are composites. Next slide, please. One of the very interesting things about Trellis, though, is if we look at the number of pods that would be required to be active simultaneously in a city such as Toronto, we estimate about 200,000 for passenger pods, some of them privately owned and some of them publicly owned, and 50,000 cargo pods. So imagine all of these pods navigating a grid, and never stopping. Now, when I say that, of course, if you're getting on and off Trellis, it pulls into a siding. We've invented a switch that is motionless, so we can put switches everywhere. You pull into a siding either to connect with the building at the second story, or for the system to lower you down to the ground level. But if you had that volume of pods, it's an amazing challenge how to envision even how to test that from an autonomous perspective, because we want it to learn. Like, for example, if people typically order on their way home, they want bread and cheese in one area, and another area prefers salami and bagels. The system might already be preloaded with those items for the right areas of the city. So when you get off your pod, that bread and cheese that you wanted is literally coming in on the next pod, and a little robot gets out, or maybe it's gotten out moments beforehand. It has anticipated your need, but at the same time, it has to anticipate the routes for everyone. Next slide. So the real vision here, and I'm hoping somebody. It's hard on these calls because I don't get to see faces, but I'm hoping this is starting to click. If we look at today's cities, it's all about concrete and tarmac covering the earth, covering nature. And why is that there on the surface? It's there because all of our vehicles are designed to move on the surface. It's not that we want that. So as soon as we adopt a system where we're above the surface, we can now replant trees and shrubbery and really get nature back into the core of the city. So you remember that earlier slide I showed you where Trellis was up above and then LRT down below? Well, really, that's the beginning point. But ultimately, what we're looking for is a world where it's green. So with QA consultants, we've been doing testing of our current robots. And there's just multitudes, potentially millions of scenarios just with the current robots. You can imagine with Trellis how many different scenarios will have to be tested with all these level crossings. We're really excited by this, and we're excited to save the planet in terms of the weight of the machinery that's moving with individuals. And you see that little graph down there. Literally, if you're riding on an LRT and it's not full, you're wasting a huge amount of energy. I think everybody knows that. And of course, if it's a subway, it's even worse. So the goal here is let's look for a future where AI can merge with smart systems to bring nature back into cities. Anyway, thanks very much, Jennifer and QA. I enjoyed it.